Hello, good morning, everybody. Not sure, I'm having some weird issues. Sometimes I feel like I show up on camera, sometimes I don't. It looks like, at least according to my screen, that I'm not showing up. I think it's maybe an issue with my computer, I'm not sure. But anyways, whatever, it is all good. So I'll just start sharing my screen right off the bat. And I hope you guys are having a great day. I'm on the little slightly sleep deprived side, but it's all good. And my day is off to a great start. It's raining, but I still got my Phil's coffee. Without further ado, let's jump into the SAT practice problems. So today we're going to be working on linear equation word problems from Khan Academy. Again, you can see up here, right? It says there's a calculator crossed out. So this means it's from the no calculator section. There's a real section on the SAT. It means that you cannot use your calculator. And again, stressing the importance of mental math and the ability of having just general number sense. So let's jump into the first problem. We're just going to get right through them. So here we go. First, Dimitri is helping to plan the school talent show. Each performer for the talent show has 6 minutes for his or her performance. I'm just going to write down 6. Which includes transition time between performances. If the introduction for the talent show is 24 minutes long, okay, I'm just going to put a 24 here. 24 minutes long, and the entire show, including the introduction, will last 150 minutes. How many different performances can the talent show accommodate? So these are the two components here as far as adding up to the total. But this 6, again, the 6 minutes has to do with it's per performer. But we don't know how many performers there are. Guess what? We need an X there because basically, think about it like this. If we have one performer, that act will take 6 minutes. 2 performers, it'll take 12 minutes, so on and so forth. We're multiplying that 6 by the number of performers that there are. So we got an X there. We're adding it to this 24 because these are both time frames of being combined together. And then it's telling us that this whole thing will last 150 minutes. And now all we have to do, how many? Again, remember, X is the number of performers. Now we just got to solve for X. So let's go ahead and isolate. We can subtract 24 from both sides. This goes away. So we now have equals 126 equals 6. I believe, let me see. I think, yeah, it definitely goes in equally. So, oops, I forgot the X. Now let's divide. We want to get rid of this 6. So let's divide both sides by 6. Divide both sides by 6. Now you could do long division. The way that I do it is I say 6 goes into 120 20 times. So to go into 126, it must be it must be 21. One more time. X equals 21. So they could be 21 performers. And let's go right for it. All right, excellent. So that is correct. Now let's go to question number 2. There we go. The property taxes in a town, in a town decrease as the distance from the local elementary school increases. The greatest property taxes are 4.5%. I'm just going to write this down here. 4.5% for 10 miles. Property taxes decrease by 0.5 percentage points. Wait, sorry. And for every, no. Greatest property taxes, the greatest property taxes are 4.5%, and they decrease by 0.5 percentage points every 10 miles. For every 10 miles from the school. Let me just make sure that I'm reading this right. Decrease as the distance from the school increase. Got it. So the farther away you get by 10 miles. So this means I understood it incorrectly at first. The closest home to the school would be charged at 4.5%. And then every time you get 10 miles away, it drops 0.5 percentage points, so on and so forth. So we could say, okay, so it starts at 4.5 percentage points minus, all right, the greatest minus 0.5 times X. This could be, and X would be like every 10 miles, right? If it's 10 miles, it'd be 1, 20 miles would be 2. We may have to modify this, but this is roughly it. So then it says, if a house's property taxes are 3%, what is the distance of that house from the school? So think about it like this. It starts at 4.5%. We assume they're like right next to the school. And then in order for this guy to equal, let's say 3%, Okay. Oh. Excuse me. Sneezing. All right. In order for it to be 3%, what we have to solve for x. So let's go ahead and subtract 4.5 minus 4.5. This goes away. Now we've got negative 1.5 equals, negative 0.5x. And then we divide both sides by negative 0.5, divide both sides by negative 0.5. And we get x equals, I'm just going to reorient this, x equals 3. But this doesn't mean 3 miles. Again, this represents a set of 10 miles. So if we got x equals 3, it means that it is 30 miles from the school. All right. I hope that makes sense. Again, I mean, I could have modified it. You see what they've done, they actually divided it by 10. They threw that in the equation. Well, the way that I did it, I just sort of recognized that x, each one for x represents 10 miles. So it's up to you. Let's move on to number 3. All right, let me delete this. Dahlia is installing a tile floor in a rectangular room. I'm going to right off the bat draw a rectangle. Always. Dahlia has 152 tiles available to the room. Maybe I'll say 152. If each row requires 9.5 tiles, so each row, so we could say a row is like kind of going across like this. Oops, something like this. So it's almost the length. 9.5 tiles, and 19 tiles break while Dahlia is laying the floor. So we're down 19. Okay, so 152, we've lost 19. So now we're at 133. How many full rows of unbroken tiles can she install before running out of tiles? So let's take a look. Now you could incorporate that, what is it called? The 19 in the equation. It's a minus 19. I just went ahead and subtracted it ahead of time. It's sort of, I mean, it's kind of up to you, however you want to think about it or visualize it. But we could say now she has 133 left to play with. And each row is 9.5. Let's get rid of the fraction. I'm going to convert it to a decimal. Times x. Okay, why did I put this x? This x is the number of rows. It's literally going to tell us basically, like, right, if we lay one row, it'll be 9.5 tiles. 2 rows, 19, so on and so forth. Now we just solve for x. So let's go ahead and divide both sides by 9.5. Again, this is a no calculator section, so you got to be decent with mental math. Now, we could just sort of try and do this mentally. What I'd say it's 10. I'd say it's 13 is my guess, but let's go ahead and actually divide it. And again, it says how many full rows, so maybe it doesn't go in equally. And 13 is not an option, so that's not precise. So let's see what we actually get. 9.5. We're going to move this decimal over, this decimal over. Okay. So now we got 95 goes into 133 once. 95. That's no surprise there. 2, 13 is 8, 0, 12, 3. Okay, so 380. And then 95 goes into 380. Oh, it's 4. Yeah. 4. So this is going to be 14 because 4 times 90 will be 360. 4 times 5 is 20, so it's 380. It goes in exactly 14 times. So my mental math was a little off there. Okay, there we go. Let's go on to number question 4. Phytoremediation. I don't know if I'm pronouncing that right. Is the use of plant growth to purify pollutants from soil, water, or air. Suppose that a crop of brake ferns can remove 15 milligrams, again, writing that number down, 15 milligrams per square meter of a particular pollutant from the soil in 20 weeks. So 20 weeks, got 15 milligrams. So after 20 weeks, the ferns are harvested and a new crop is planted. If C represents the number of crops of brake ferns needed to phytoremediate soil contaminated with 170 milligrams per square meter of the pollutant down to healthy levels of 5 milligrams per square meter, which equation best models that situation? So, okay, so now we don't even have to solve this. We're just sort of trying to figure out how to model the situation. So think about it. We're starting at 170. All these guys have 170 here. Now, again, this is being reduced, right? So it's 170 and it's being reduced each time by, what is it? C represents the number of crops needed to photoremediate. So let's see, so 15 milligrams. Hold on, let me see this. Suppose that a crop of brake ferns can remove 15 milligrams in 20 weeks. So we need to say, sorry, if C represents the number of crop farms need to phytoremediate contaminated with 170 milligrams per square meter to healthy levels of 5 milligrams. So each, and this is the number one. So, oh, I see. I get it now. Okay. So we've got 20 weeks, and the question is, are we using 20 or are we using 15? So I'm just trying to wrap my head around this, because this, again, is one of those crazy ones. So 15 milligrams, and then this one is 20 weeks. So 20 weeks, but we don't care about the time. We care about that 15. So this 20 is kind of like, it's a red herring, because this would model like the number of weeks. So we've got whatever, 5, 10, 15, so on and so forth. It doesn't matter. But we're talking about this guy. Okay, hold on. Just wrap my head around this a little bit more. 15. And once again, C represents the number of crops of brake ferns needed to phytoremediate the soil with 170 and down to 5. So let's see if does that make sense? So in 20 weeks. So 15, 20. Yeah, I think it's this one. This is actually a little bit tricky. I think it's this guy here. Okay, I just want to read exactly what it says. Each crop reduces the pollutant by 15 milligrams per square meter. Oh, did it even say that? See, I missed that. Oh, yeah. Okay, per square meter. Yeah, it doesn't, because see, they're not asking about time. See, that's what this one actually threw me off for a second. But they're not necessarily asking about time, and that's why this guy here is a red herring. God, see, that's what they do with these questions. They sort of throw in all these different terms that cloud it and make it a little bit difficult to understand. All right, let's move on finally to question number 5. So here we go. All right, one of the rules in a public speaking contest requires contestants to speak for as close to 5 minutes, which is 300 seconds. And I think we're talking about seconds here, so I'm going to put 300 as possible. Contestants lose, and again, I already know, I can see the absolute value, and I get why, but I'll explain that in a second. Contestants lose 3 points for each second they speak, either over or under 5 minutes. So if it's 305 or 295, they're going to lose they're going to lose the same amount of points. They lose 3 points each time. Oh no, I'm sorry. For each second. Sorry. So 301 or 299, in both of those cases, they lose 3 points. Which expression below can be used to determine the number of points a contestant loses if she speaks for X seconds? So think about it like this. Let's say we want to know the difference between, so they want you to be like right on 300. So we want to know the difference between X and 300. Okay, because that is going to give us, whether they're over or under. But think about it. It's going to be interesting, because if this is over 300, this quantity right here will be negative or positive. If it's under, it'll be negative, right? So like if you went again 301 minus 300, 71 minus 300, this will be -1. But it's like you're still losing points. So we don't want one to be negative, one to be positive. So this is where the absolute value comes in. It's X minus 300, but they're taking the absolute value, and no matter what, every time we're losing 3 points. So each one of these guys, we're then multiplying it by 3. So just like up here, we'd be multiplying this by 3. Again, they're throwing this 5 minutes number in here. It's almost to like confuse you. Or sorry, in this choice. So B, we have a 5. D, we have a 5. That's just a red herring. So the question would kind of come between A or C. And again, as I already showed, we're not adding this X to 300. 300 is our cap. We're taking the difference. So that's why we would go with A. All right. Let me try and turn the camera back on. I don't think it's going to work. Hope that was helpful. Let's see. So stop sharing. Yeah, again, so I'm not on camera. It is what it is. Hope you guys have a great Friday. Hope that was helpful. And we will start this back up again on Monday. I'm going to try my best to jump through an entire SAT calculator section this weekend, but in a much slower way than I did last weekend. And the coolest thing that I'm excited about is a new music video on SOHCAHTOA will be coming out next week. Fingers crossed Monday. A very busy weekend, but hopefully that will be the case. So that's it for today. Thank you guys so much, and I will see you next time. Take it easy.